How many members they attended for the physics class?
3, sir. 3 or 4.
3 or 4. Okay, so you only attended the chemistry. That's why I'm asking here.
So only one person, another girl, that's it. That's it. Attended.
Okay, okay. So in last class you didn't attend, na?
No,
In
sir.
last class, we started with the alcohols, phenols, ethers chapter. Okay.
Yes, sir.
So in that one, we started the preparation of the alcohols. Just briefly, I'll give the explanation here. So we can prepare the alcohols. How we are going to prepare the alcohols?
From alkenes, from hydroboronation, from
Very good.
nuclear substitution.
Very good, man. So whenever they had given the unsymmetrical alkene means addition of water molecule, it forms as a which rule, ma? Markovnikov rule. What is meant by the Markovnikov rule, Samhita?
Sir, the group will get attached to the carbon which has the less number of hydrogen atoms.
Very good. Okay. And reaction with Samhita, one more question here. So what is another question? So in this only, from alkenes chapter only, you must read about this one thing. So oxymercuration, demercuration reaction, one it is that. Do you have any idea about that one here?
Which one?
Oxymercuration and demercuration.
Adding mercury and also removing mercury?
Yes, ma. Oxymercuration and demercuration.
Is it adding mercury with an OH group and then removing mercury?
Very good, ma. But here, so finally, what is the product you will get in oxymercuration reaction and demercuration reaction? What is the product you will get?
OH?
Okay, very good, ma. Alcohol we are going to form here. So what is the product you will get as here? So we'll get as a alcohol is the product. So how will we get as a alcohol means, for example, we have to take, if you take the unsymmetrical alkene, if it is symmetrical means we don't have any problem. For example, CH2 ethene. What is the molecular formula of the ethene? CH2 double bond CH2. If the CH2 double bond CH2, if it is treated with mercuric acetate, first of all, okay, mercuric acetate. So mercuric acetate molecular formula is HgCH3COO taken twice. Okay, after that it undergoes to the hydrolysis reaction. After that, if it undergoes the hydrolysis reaction, this is the first condition. This is the first condition. And what is the second condition means here? In the second condition, again it undergoes to the reduction reaction. What is the reducing agent we can use means NaBH4, sodium borohydride we are using. If the alkene is ethene is treated with mercuric acid in presence of water, then it undergoes to the reduction reaction means it forms as an alcohol. Okay. Now what is the product it forms means CH3 bond CH2 OH it is going to be formed. Okay, so it forms as a CH3 bond, CH2 bond, OH. If they had given unsymmetrical alkene, if they had given as a unsymmetrical alkene, for example, CH3 bond, CH double bond, CH2. If it is treated with, mercury acid, what is the product it is going to be formed? Which alcohol you will get the product? This is in presence of H2O plus NaBH4. Any guess?
Sir,
Any guess?
it will form at the second carbon.
Okay, OH group is going to be attached to the second carbon atom. Okay, so OH group is going to be attached to the second carbon atom. Okay, now according to that one, if the OH group is attached to the second carbon atom, means what is the alcohol it is going to be formed? CH3 bond CH bond CH3 bond OH. So it forms as a secondary alcohol. Now you got the clarity if it is having symmetrical and unsymmetrical one. Got it?
Yes, sir.
Okay. And one more question, Mahi. Bonus. Okay. Now I'm going to give us one more question. bond CH, double bond CH bond CH3. Okay. Any guess based on this one? OH group is going to be attached to which carbon atom?
So the second one.
Can I give the numbering here? Okay.
The second one.
2, 1, 2.
Sir, is it the second one?
Second one or first one? Ma? Second one or third one? I give the numbering here. Second or third?
I'm thinking
Third,
second.
sir, third.
Samhita is which carbon atom?
Second one.
It's not the second one.
Third
Ritu?
one.
Third
It's
one is
third,
that.
sir. I just confused in the numbering.
Because of benzyl carbon is more reactive. Ma.
That is the third one, right?
It's the third one. Ma. Because of benzyl carbon. Okay. After the benzene, whatever the carbon it is that we can call as a benzyl carbon. So OH group is attached to the benzyl carbon atom. Okay. CH bond OH bond CH2 bond CH3. Here if you see means this one you will get as a secondary carbon. So here you will get as a benzyl carbon. If you compare the secondary carbon and benzyl carbon, which one is more reactive? So benzyl carbon is more reactive. Due to that reason only OH group is going to be attached to the benzyl carbon. This is the one method we are using in the preparation of alcohol. By using the oxymercuration and demercuration reaction also we can prepare as a alcohol. Okay. So I think so we had seen three methods. First one is addition of water molecule. Second one is hydroboration oxidation reaction. Okay. Hydroboration oxidation reaction is it follows the anti-Markovnikov rule. Hydroboration oxidation reaction is it follows the anti-Markovnikov rule. And oxymercuration demercuration reactions are in oxymercuration demercuration reaction also it follows the Markovnikov rule. Oxymercuration demercuration reaction are it follows the Markovnikov rule. Now you got the clarity. Still anyone having doubt? Sometimes they're asking the question. Oxymercuration demercuration reaction is follows anti-Markovnikov rule or Markovnikov rule or Sagejeff rule. What is the answer? What is the answer, ma? Oxymercuration demercuration reaction is follows. First option Markovnikov rule, second option anti-Markovnikov rule, third option Sagejeff rule, and fourth option none of the above.
Could you repeat the question?
Once again, I'm repeating the question. Oxymercuration demercuration reaction is follows. First option Markovnikov rule, second option anti-Markovnikov rule, third option Sagejeff rule, fourth option none of the above.
Sir, it sometimes follows Markovnikov, not always, right? So
Where this one? Everywhere we are taking as a Markovnikov rule only na in oxymercuration demercuration reaction.
so phenyl is also part of the Markovnikov rule because phenyl is more reactive.
Yes, ma. Benzyl carbon is more reactive. Okay.
Okay,
So
okay.
where we are going to add the OH group negative ion on it all means based on the reactivity. The carbon which is more reactive for that only negative ion is going to be attached. In that one, if you see the reactivity order, which carbocation is more reactive means here, benzyl carbocation is more reactive than allyl carbon. Allyl carbon is more reactive than tertiary. After that, secondary. After that, primary. Now you got it clarity?
Yes, so it follows Markovnikov's rule.
Yes. Okay. Is it clear? Then, so these are the different methods. And sulfuric acid also, if you treat it with the concentrated sulfuric acid, then it undergoes to the hydrolysis reaction also. It forms as an alcohol. Okay. Sulfonation reaction also it forms as a Markovnikov rule. Okay. What is the sulfonation means? Addition of sulfuric acid to the alkenes. Can I give only one example? Reaction with sulfuric acid. Okay. Now let's see. I'll give one example. Sulfonation reaction. sulfonation reaction. So alkenes are treated with sulfuric acid. For example, directly I'm taking as unsymmetrical alkene. CH3 bond, CH double bond, CH2. If it is treated with the sulfuric acid, H2SO4, H2SO4. In this one, what is the electrophile and what is the nucleophile, ma? What is the electrophile and what is the nucleophile in sulfuric acid? Actually,
Sir, electrophile is the positive one, right?
yes, ma. If it undergoes the ionization, means it forms as a H plus, and we can take as here SO 4H minus, it will be there. SO 4H minus. Now let us see after addition here. So this also it follows the Marconi curve rule. This also it is follows here Marconi curve rule. Now CH3 bond, CH bond, SO 4H bond CH3, it will be there. H plus is going to be attached to this carbon atom. Again, the given molecule is unstable. If it is unstable, means again it undergoes to the hydrolysis reaction. Hydrolysis reaction means addition of water molecule. If you add the water molecule, means OH group is going to be attached to this carbon, and H is going to be attached to sulfur. Okay, so according to that one, CH3 bond, CH bond, OH bond, CH3 again plus H2SO4. Okay, simply this only we can call as a acid hydrolysis reaction. That means the reaction is carried out in presence of acid. Okay, so acid hydrolysis also it forms as a alcohols. Based on the reactant, we may prepare as a primary alcohol, we may prepare as a secondary alcohol, and we may prepare as a tertiary alcohol. So, got the point? By the sulfonation reaction also we can prepare as alcohol. That is the one method. Okay, and we have another method also. So what is another method we are using in the preparation of the alcohols? Means here from carbonyl compound, from carbonyl compounds. What is meant by the carbonyl compounds? What is mean by the carbonyl compounds? What is mean by the carbonyl compounds? Any one of you? So which we can consider as a carbonyl compounds?
Sir, which has double bond O present in them.
Very good, ma'am. So the compounds which contain the C double bond O group is called as a carbonyl compounds. But generally in this condition, what we are taking means we are taking as a aldehydes and ketones. We are taking as here aldehydes and ketones. Okay. So what is the general formula of the aldehydes? What is the general formula of the aldehydes, ma'am? R bond CHO. Is it right? Is this the aldehyde or not? What is the functional group of
Yes,
the aldehyde? CHO, C double bond O H attached, C double bond O group is attached with the H means that it converts into the aldehyde. C double bond O group is containing the any alkyl group means it is converted into the ketone. So ketone functional group generally we can write as R bond C double bond O R. RCHO, RC double bond OR. Okay. Now, first one is we can call as a aldehyde. Second one is called as a ketone. Okay. First one is called as a aldehyde. Aldehyde. Second one is called as a ketone. Okay. Now, let us see. When the aldehyde is, it undergoes to the reduction reaction. When aldehyde is, it undergoes to the reduction reaction. Okay, it undergoes to the reduction reaction. What are the reducing agents we can use? What are the reducing agents we can use?
H2, sir.
No,
Agents, ma'am. Talking about the agents.
sir, we can use H2 in the presence of
PD
zinc
sulfide.
catalyst.
Catalyst. Very good. So nickel or platinum or palladium also we can use. Next is any other catalyst?
DILBO4.
Okay, ma Di
Sir, I forgot the molecule form, but it's DILBO4 or something.
DIBAL
Okay, yeah, DAL.
BALH. Okay, Dibol generally we can call Dibol. Di-isobutyl aluminium hydride. What is the abbreviation of the Dibol means here? Di-isobutyl aluminium hydride. It is also act as a reducing agent. Okay. And what are the another reducing agents we are having means here? Zinc in presence of HCl or zinc in presence of ethyl alcohol, ETOH. Okay. So zinc amalgam, ZnHG sir. ZnHG is converts carbonyl compounds into alkene. So we can't take as a this one. Okay. And what is another one we can take means here? Lithium aluminium hydride. We can take as a lithium aluminium hydride, LiAlH4, and sodium borohydride, NaBH4. Lithium aluminum hydride and sodium borohydride. All these are the different reagents we are using. Okay, so now you got the clarity, all of you. Now you got the clarity. Now my explanation is, let us see how we are writing as a aldehyde group. Generally we are writing as a aldehyde C double bond O. Okay, you are adding as a one hydrogen molecule. In that one, how the hydrogen molecule is going to be added means first R bond C H, it is there. Here one oxygen atom it is there. There one oxygen atom it is there. Okay. Right, ma? Here, let us see. Here CH and H it is there. So that we are adding as a hydrogen molecule. If you add the hydrogen molecule means CH is converted into the CH2 and pi bond is replaced by the two hydrogens. That means one oxygen is, the oxygen is attached with the one hydrogen. If it is attaches with the hydrogen means it is converted into the alcohol only. Na? So in this method, whatever the alcohol you got, either it is the primary alcohol, secondary alcohol or tertiary alcohol. Whatever the product you got, that is primary alcohol or secondary alcohol or tertiary alcohol.
Sir, is it primary?
Very good, Ritu. It is a primary alcohol.
So primary?
Yes, ma'am. It is primary alcohol only. So aldehydes are converted into primary alcohols. Aldehydes are converted into primary alcohols. Then what about the ketones? Ketones are converted into, how they convert the ketones?
They convert into secondary alcohols?
Very good, Ritu. So ketones are they converted into secondary alcohol. That means R bond, CH bond, OH bond, R. Okay, R bond, CH bond, OH bond, R. So this it becomes as a secondary alcohol. Okay, sometimes they're asking the question. So what is the question means here? For example, if acetaldehyde, acetaldehyde acetaldehyde is, it undergoes to the reduction reaction in presence of lithium aluminium hydride. Okay, so the product is either primary alcohol, secondary alcohol, tertiary alcohol, or none of these. Acetaldehyde is, it undergoes to the reduction reaction to form, once again I'm repeating the question, ma. Everyone listen carefully. Acetaldehyde is, it undergoes to the reduction reaction to form primary alcohol, secondary alcohol, tertiary alcohol. Acetaldehyde. Any guess? Ritu, Aditi, Samhita. What is the molecular
Sir, is
formula
it
of this?
primary?
Very good, Aditi. Very good, Ritu. It is a primary alcohol. What is the molecular formula of the acetaldehyde?
C2H4.
C2H4. Oh, that is also we can write as a CH3 bond CHO. CH3 bond CHO. When it undergoes to the reduction reaction, that means you are adding as a one hydrogen molecule. If you add the hydrogen molecule, means it is converted into CH3 bond CH2 bond OH. So this we can call as a ethanol. This we can call as a ethanol. Okay, and this also we can call as a ethyl alcohol. So ethyl alcohol is a primary alcohol, secondary alcohol, or tertiary alcohol. Ethyl alcohol is primary or secondary or tertiary? It is primary alcohol. Now, one more question. Another question. Acetone. Acetone. If the acetone is reduced with sodium borohydride, NaBH4, then what is the product it is for me? What is the IUPAC name of the product? IUPAC name of product.
Sir, could you repeat what you asked again? I couldn't hear.
Acetone is reduced with sodium borohydride. Okay, so it forms as a product. What is the name of IUPAC name of the product? What is IUPAC name of the product?
Sir, is it 2-propanol?
Hmm?
I'm not sure if it's. Is it like 2-propanol?
2-propanol. It is correct only, ma. What is the name of the product? Means it is the 2-propanol only. So CH3 bond CH bond OH bond CH3. So 1, 2, 3. So root word we have a 3 carbon atoms. While having the 3 carbon atoms, we can write as a root word is pro. The given compound is saturated compound and ane is the suffix. And we have a secondary suffix. What is the secondary suffix? Means alcoholic functional group. What is the position of the alcoholic functional group? Means second position. Propane 2 also we can write. This also we can write as a 2-propanol. That also we can write as a 2-propanol also we can write. So now we got the clarity. So anyone you having doubt? Is anyone you having doubt?
No, sir, got it.
Okay, next one. Here one more condition is there, ma. What is another condition? Is not only aldehyde here,
Yes, sir.
so we can take as a esters. Sorry, first carboxylic acids. What is the general formula of the carboxylic acid? R bond COOH. R bond COOH. If the carboxylic acids are reduced with lithium aluminum hydride in presence of H2O or sodium borohydride NaBH4. NaBH4. It undergoes to the reduction reaction. If it undergoes the reduction reaction means they converted into the alcohol. That means carboxylic acids also reduced with either lithium aluminum hydride or sodium borohydride. They converted into the alcohol. How they converted means they converted into the primary alcohol. Carboxylic acids are converted into primary alcohol. Sir, what is the example for that one means formic acid. What is the molecular formula of the formic acid? Molecular formula of the formic acid, ma. HCOOH. If it is reduced with lithium aluminum hydride. Lithium aluminum hydride means it is converted into CH3OH. Okay. For example, if you take acetic acid, CH3 bond COOH. If it is reduced with lithium aluminum hydride in presence of H2O, it is also converted into ethanol, CH3 bond, CH2 bond, OH. That means OH group is attaches to the terminal carbons only. If the OH group is attaches to the terminal carbons, that we can call as a primary alcohol. Okay. Here, and another condition. What is another condition means here? From esters also we can prepare. From esters. From esters also we can prepare as alcohols. Okay. So in this one, what is the reagent we are using means lithium aluminum hydride only we can use. We cannot use as a sodium borohydride for the conversion of the ester into alcohol. Okay. Sodium borohydride NaBH4 does not reduce ester into alcohol. It's not going to be reduce the esters into alcohol. Why it's not reduced into the ester into alcohol means lithium aluminum hydride is it act as a strong reducing agent. It act as strong reducing agent and reducing agent, and it is the selective reducing agent also we can call selective reducing agent. So why we are calling as a selective reducing agent means here we cannot use as a lithium aluminum hydride. So because of lithium aluminum hydride it's a very cost is more for the lithium aluminum hydride. Okay. Agent. So it is very costly here. So a strong reducing agent and it is selective reducing agent. So why it is the selective reducing agent means only for particular reactions only we can use as a lithium aluminum hydride. Okay, so only for particular reactions only it is going to be act as a reducing agent. It is not used for all the reactions. First of all, it is very costly. If costliest material means we cannot use for the simple reactions also, no? Is any possibility is there to use? Simply costly materials we cannot use for the simple things. Are you going to use? No, we cannot use as a lithium aluminum hydride here. Okay, so that's why where we are using is especially for the conversion of ester carboxylic acids and esters. To conversion of the carboxylic acids esters into alcohol, we can use as a lithium aluminum hydride as well as sodium borohydride. Carboxylic acids are reduced by the lithium aluminum hydride and sodium borohydride, but esters are reduced by only lithium aluminum hydride. Now you got the clarity? All of you got the clarity?
Yeah, sir, got it.
Okay. Now for that one, I'll write as one example here. So what is another example means here? COOR is called as a ester. COOR. The esters are reduced with lithium aluminum hydride. So one is converted into RCH2 OH, another one is converted into ROH. Okay, it is converted into the alcohol. So by using this method, we can get as a mixture of alcohol. So mixture of alcohols can be separated by the fractional distillation method. Okay, so mixture of alcohols can be separated by the distillation method. For example, if I had given methyl ethanoate, that means CH3 COO CH3, sir. So this we can call as a methyl ethanoate. Methyl ethanoate. If the methyl ethanoate it undergoes to the reduction reaction in presence of lithium aluminum hydride and water molecule. Okay, it undergoes to the reduction reaction with the lithium aluminum hydride and water molecule. If it undergoes to the reduction reaction with the lithium aluminum hydride and water molecule, means it forms the products. What are the products it is going to be formed? Means this one. So CH3C, CH3 COO group is converted into CH2OH. Okay, CH3 COO. This part is converted into the CH3 CH2OH. That means we can convert into the ethanol. It is converted into the ethanol. And the alkyl group which is attached to the carbon here. Okay, that it is converted into CH3OH. So this we can call as a methanol. Sir, where we are taking as a reduction means exactly here. 2 carbon atoms are there. 1 carbon we are giving to the alkyl group. Another one is attaches with the another one here. Now you got the clarity. If you divide exactly here, means this side we are adding as a 2 hydrogens and 3 hydrogens we are adding, and here we are adding as a 1 hydrogen. Whenever you add as a 3 hydrogens, means it is converted into CH2OH group. And that side one, if you add 1 hydrogen atom, means it is converted into CH3OH. Okay. Can I give one example to you to make you clear? To make you clear, I'm giving one more example to you to make sure. Here, ethyl ethanoate, CH3 bond COO. Sir, to make you clarity, I'll write clear structure. Ester structure, I'll write clearly. C double bond O bond O C2H5. It is reduced with the lithium aluminum hydride. Any one of you can guess the product? What are the products it is going to be formed? What are the products it is going to be formed, ma?
Sir, ethanol.
How many moles of the ethanol it is forming, Ritu? Ethanol is correct answer only. Only ethanol is other
Sir,
products also.
sir,
With
2,
2 moles.
2
2 moles is
CH3, CH2, OH.
very
So
good. Very good, Ritu. Very good, Ritu. So let us see, ma. So simple logic. Ester, I am breaking here this side exactly in between the carbon and oxygen. Okay. So ester can be represented like this. So this side I am writing as a 3 hydrogen. This side 1 hydrogen. So CH2OH. So first one I am writing as a CH2 C2H5OH. C2H5OH. Another one as this I am writing here. First methyl group it is there. After that CH2OH group it is there. After that CH2OH group it is there. Now if you see here also C2H5OH, here also C2H5OH. That means how many moles of the ethyl alcohol it is forming? How many moles of the ethyl alcohol it is forming? It forms as a 2 moles. Is that directly you can write as a 2 moles of the C2H5OH is the product. Now we got the clarity. If the ethyl ethanoate, what is the name of this one means here? Ethyl ethanoate. Ethyl ethanoate. If the ethyl ethanoate is, it undergoes to the reduction reaction with the lithium aluminum hydride. It forms as a product. It forms as a ethyl alcohol. Now we got the clarity. By the reduction of the esters, by the reduction of the carboxylic acid, both the cases, which alcohols you got? Either you got as a primary alcohol, secondary alcohol, or tertiary alcohol. In both the cases, which alcohol you got, ma?
So which is the main product formed?
Both are same products only. How we can consider it as a major product and minor product? Both are important only.
Same.
sir, it's primary.
Yes, sir. All the cases you are getting as a primary alcohols. Primary alcohols. Now I'll tell one more thing here. So I can tell one more thing. Yes, CH3 bond, JEE level question mark. CH double bond, CH bond, COOH. JEE level concept question mark. Or CH double bond, CH bond, COOH. Both the cases, lithium aluminum hydride only. Here also lithium aluminum hydride. Okay. So first one, what is the product, and second one, what is the product? Any guess? Any one of it, just if you tell, I'll write the answer. What is the product it is going to be for? JEE type question. Exception case it is that. That's why I'm asking. You want to know the clarity. Is lithium aluminum hydride is reduces only carboxylic acid and unsaturated site also, ma? Is lithium aluminum hydride is reduces carboxylic acid as well as unsaturated site, or it reduces only carboxylic acid? Condition apply. Sir, when, let us see. So this is the alpha carbon atom. This we can call as a beta carbon atom. Okay. So when the functional group attached to carbon is called as a alpha, and here also we have a alpha, here also beta it is that. Okay. Now, if the beta carbon atom is attaches with the phenyl group, if the beta carbon atom is attaches with the phenyl group, whenever it is attaches with the phenyl group, lithium aluminum hydride is reduces functional group as well as double bond. Okay, now we got the clarity. Once again, I'm repeating the statement. So when unsaturated carboxylic acids are containing beta phenyl group, that means beta position, if the benzene ring or phenyl group it is there, means it reduces unsaturated side as well as carboxylic acid. So that means the finally the product is, it forms as here. We can write like this here. Bond. Yes, CH is converted into CH2, bond CH2, bond COOH. So 1, 2, 3. Okay, so this we can write as a 3-phenyl propanoic acid. 3-phenyl propanoic acid. 3-phenyl propanoic acid. Then what about the first one? If first one is, it undergoes to the reduction reaction, sir. What is the product it is going to be formed? What is the IUPAC name of the product? Sorry, this one not COOH, this converts into the alcohol. This converts into the propanoic, not the propanoic acid here. It is converted into the alcohol. Carboxylic acids are converted into the alcohol now. And CH2OH. This we can call as a 3-phenyl propanol. Okay, what is the answer for this one? Anyone now? Can you please? Time is up.
So
Aditi,
CH3,
CH3 Aditi. Somebody that telling that. Next
CH2,
one. CH.
2.
It won't be converted into the CH2 group because of beta carbon atom is attaches with the methyl group. It is not the phenyl group. When double bond is converted, unsaturated site is converted into the saturated, means when the beta position phenyl group or benzene ring it is there, means that time only it undergoes to the reduction. So it's not going to be reduced. That means unsaturated site is not going to be reduced. CH3 bond, CH double bond, CH bond, it reduces only carboxylic acid. Carboxylic acid is converted into the alcohol, CH2OH. This is the answer. Got it clarity?
Yes, sir.
Samhita, Aditi, Ritu, it's JEE and NEET type question. Ma. JEE and NEET type question. Previous year question also it is there. Okay, so condition when it is going to be reduced means whenever it is having that beta position, the benzene ring it is there, then only it undergoes to the reduction reaction. Otherwise, it not going to the reduction reaction. Okay. Right, my remaining concept we'll discuss in the tomorrow. Until here, just to go through once. Right, ma?
Thank you, sir.
You're welcome.
Thank you, sir.
Welcome. We will continue in the tomorrow class.